Certainly now that everyone can hear me, thank you very much for attending and welcome to the Voltimum webinar series. This is the second in the series, so I get the silver medal. I didn't get the gold medal, but at least I didn't get the bronze, and we did win the Ashes, so it's all good. My name is Mark West. I work for a company called Sylvania Lighting, and we are known for the brands that you see on the presentation there, as well as other brands such as Siteco, Gadini. We're fairly well known for our outdoor lighting, our brand of lamps, and we certainly are across most sectors of lighting. We have a lot of interior architectural range, outdoor lighting, a lot of street lighting and infrastructure lighting. So please, if there's any questions about Sylvania specifically, please drop me in a question. My contact or the company's contact details are on the last slide. So thank you. Alright, I'd like to talk a little bit about LEDs, but before we do that, certainly the LEDs have become synonymous with lighting, almost to the point that they have supplanted lighting. We don't talk about lighting now, we talk about providing LEDs. LEDs are just another light source. All light sources, conventional and new technology, all have a novelty, all have a utility, and all can be used in certain applications. I'd like to talk a little bit about lighting first, and then how we fit LED into that lighting. You'll see the overview, the introduction, talk about the technology, the applications. We will talk about summaries. If you have any questions, as I say, please put them in the chat. If I can answer them as part of this presentation, I'll do so. If I can't, I'll try to get to them at the end, and if we run out of time, I'll have somebody contact you with the answer. I could talk a little bit about light. Light is essential for our well-being. It's our job in the lighting industry to make artificial lighting systems as natural and as efficient as possible. It does get dark half the time, and we do need artificial lighting. If we light an object in different ways, you can completely change the mood and the visual effect of this. If we light her in warmer colours, we tend to get a more red effect, warmer, more comfortable feeling. If we change to more natural light, you get a completely different effect. It's our role as lighting experts to understand these changes and how to accentuate the textures and simulate them with artificial lighting. So in the chat, has anyone picked who the painter is? Can I have see if anyone can guess the painter? No, not Van Gogh. No, not Van Gogh. Thank you, Colin. Monet. This is what Monet had to say about lighting. Form only exists through light, and our perception of the world around us is totally dependent on it. It's our challenge to achieve that balance between the quality of the lit environment from the user's point and the reduction in energy. This is also debated in the lighting area about lighting for the planet or lighting for the person. If we are only interested in reducing energy efficiency, which is a worthy objective, we can necessarily provide the wrong environment. It's important that lighting professionals, we try and balance that. I'll talk a little bit more about that as we go through. It's our job as lighting professionals to provide quality, uplifting environments. We can do that through technically advanced products, quality products, and providing features that provide a visual interest and a stimulation to the occupant. It is important to have good lighting design and have environments of inspiration. A little bit about the standards. These standards do help and assist with guidance for lighting, but lighting at its best is an art. Our opportunities are a greater understanding of how to achieve that energy efficiency and balancing the lighting for the individual. We have a lot of opportunity now with lighting controls, capabilities, compatibilities, new technology, and new technologies yet to come. I won't go into those, but certainly there's more exciting technologies on their way, as well as the Section J6 of the Building Code of Australia, which I'm sure you're fairly aware about, but that simply refers to watts per metre square and all of those tangible measures of energy. The subject of lighting design is quite exhaustive. I'm certainly not an expert. There's a lot more professionals in the industry than I don't want to go through the lighting design. I just want to try and set the scene that lighting is important, and lighting is the first objective. I'd like to now talk about how LEDs can fit into that lighting application. I don't think anyone on this group will be surprised to hear that lighting technology will be dominated by LEDs by 2020. Certainly in a lot of applications, LEDs are dominating currently. It's a new opportunity for us to provide better quality light with far more control than we've ever had. It currently ranks very well. There you have a chart. On the vertical axis you have the efficacy, the lumens per watt, how much light you get out for every watt of power, and then you have a time base on the horizontal axis. Currently we're operating around a system efficacy of around 100 lumens per watt, occasionally a little bit above, occasionally a little bit below, and you can see there that metal halides and sodiums currently beat it, and low pressure sodiums. But I'll talk a little bit more in a minute about how LEDs can actually be better than both those light sources. The forecasted maximum efficacy, it's open for debate. There is quite a large breadth of opinion on this, but a efficacy of around 175 lumens per watt to 200 is deemed to be where LED will actually stop improving in efficacy. And at that point there's only low pressure sodium which can beat it. Low pressure sodium is a shocking light source. It's monochromatic and very rarely used in lighting. So LEDs will indeed and have indeed overtaken a lot of the conventional technologies. So a bit of a summary, just to keep up to date where we've been. It does provide long life, energy efficiency. I haven't spoken about the fact that it's inherently rugged. They don't suffer vibration issues that conventional light sources do, where you're suspending an arc tube in an envelope. That is typically a very fragile environment. LEDs are not. They are instant. They are very directional. As I say, the lumen efficacy is good, but certainly you can increase the efficacy of your project or your product by maintaining the system losses to be minimal. You have a point source, you can put a reflector around it and get the maximum out of it. They're dimmable, you have an infinite colour palette, and you can have that varying from one extreme to the other in intensity and colour temperature. That's never been available to the lighting industry before, not to the extent that it is now. They do like cold environments, they do not like being overheated, and I'll talk a little bit more about that. So, why do you choose an LED? Energy efficiency, that seems to be the main reason for driving LED sales. Certainly the life and the reduction in maintenance is an important part, but there's also an image that is relevant to LEDs. They have no UV, very little infrared, no mercury, no lead, no hazardous substances. Again, that's fairly unusual in the lighting industry. And of course it is very important to be seen to be providing sustainable lighting for the future and for the current. It's a little bit of a summary of LEDs. I hope not to get too technical, but I'd like to talk a little bit about the detail of some of those things I mentioned. Firstly, here's just a small selection of the ranges of LEDs, from chip to through hole to surface mount to chip on board, ceramic base, silicon base. The choice is enormous, and each of these LEDs has a slightly different signature, behaviour, and the selection of the LED for the application is very important to ensure you get all those efficiencies that I spoke about. There's more variation in LED than there ever were in the conventional lighting sources, the metal halides, the sodiums, and so on and so forth. I'll try and summarise those into three main types, if I may. The traditional LED that you see at the top, the 3 to 5 millimetre through-hole LEDs, they're used for indicators, signs. You may see them in domestic devices, video recorders, televisions, etc., to show that the power is on. You then have surface mount LEDs, which are typically voltage driven, and they don't need any heat sinking because of their extraordinarily low power. And because of their low power, they are able to be put in discrete places under cabinets, decorative lighting, walkways, and that provides an opportunity to put lighting into places that hasn't really been possible to put it into before. And the recent innovation of high power LEDs, or at least the improvement in high power LEDs, is providing an opportunity to go across multiple applications. Here's a little bit more about the packages. Again, I won't dwell on this, but the current increases as you move up the power in the package, but so does the need for increased thermal management. The chip is typically made from a semiconductor device, a diode that provides electroluminescence, light from the semiconductor, which is then passed through a phosphor. I'll talk a little bit more about that. And it's all housed in a package so it can be mounted into your luminaires. Here is a diagram of most of the lighting designers will be aware of. So the question was, what milliamps should be used for the surface mount devices? For surface mount devices that are current driven, you have a various range of currents there. You can see from 20 to 100, 200 to 150. I'll talk a little bit more, if I may, just in a minute about how it's important to manage that current, because it is directly proportional or indirectly proportional to life. The higher the current, the shorter the life. But it's variable, is the answer to your question. Here's the representation of all the colours that are visible to the human eye. It's an unusual shape, but most lighting designers will be aware of why it is that shape. It's not really relevant, other than the fact that the organic LEDs, not organic LEDs, but LEDs at their lowest common denominator are typically blue. We add a yellow phosphor, which is at the far extreme of that colour range, and that brings back the colour to a white light. But it is a continuum. That white light can be yellow, blue, more tinges of red, and I'll talk a little bit about binning. If you don't manage the colour temperatures of the LEDs well, you can end up with an application such that you see there in the bottom right hand corner. That is all supposed to be the same colour light source. The selection of the LEDs, the natural variation in that colour temperature provides a shocking use of lighting. So binning, and more information if you wish, please ask us, but certainly to maintain a range of colour temperatures so that all the light sources are similar, that is called binning, and it's very important to manage that. I mentioned a little bit about the current. That's IF, forward current. The more you drive LEDs, the higher the temperature and the shorter the life. The temperature is measured at the junction temperature, and in that situation you need to maintain that. I'll show you what happens if you don't maintain that junction temperature. Here we have two charts. The one on the left is a Cree LED run at 350 milliamps. So in this instance, Justin, they're running at 350. The one on the right is run at 700. It doesn't necessarily, one is not right over the other. You can run it at quite a range of currents. But you can see that the chart on the left, the vertical axis is the life, and the horizontal axis is the temperature that the junction gets to. As you increase that temperature, you necessarily decrease the life. This is unusual. Normally with conventional lighting sources, lamps, metal halides, sodiums, mercuries, temperature, they're completely agnostic about temperature. They don't suffer this phenomenon. It is new for lighting, and it's very relevant to semiconductors, which is where LEDs come from. All light sources depreciate in their light, so they start at 100% output, and over time they will reduce in their output. You may hear the discussions of L80, L70, L50. that refers to the amount of light left at the prescribed life. So at 60,000 hours, this curve for this LED will be L70. At 45,000 hours, it will be L80. That means that there is 80% of the output of light, or 70, at that point in time. This is the determinant of the life of an LED. It's not that the LED will fail or no longer illuminate. It's the determinant of life is that the amount of light coming out the LED has dropped to a point that is prescribed to have been end of life. A little bit about the application highway. We spoke about the lower wattages, the 5 to 10 lumens per watt. In the early days, they were used for more indication lighting. We went from backgrounds to residential, and now we're in the general lighting area of around 100 lumens per watt. So I've spoken a little bit about lighting practice. I'm very rushed, I apologise for that. I've spoken a little bit about the criteria of an LED in summary, and now I'd like to talk a little bit about where LEDs are best used and how. I'll flick through some of these. I know I'm running very late on time. The surface mounted LEDs are more for indication, not for illumination. They are more for effect than actual operating lighting levels to attempt a task. Whereas the high power LEDs are again more used for providing lighting levels to operate under to undertake a task. And there we have a high current, high power, and the need for a heatsink. You can see the middle image there. That's typically the arrangement of a lens with a baffle through a collar onto the LED PCB, which is all mounted to a heatsink. It's a little bit complicated, but if managed correctly, perfectly satisfactory. So we spoke about the summary, the efficiencies. There's no heavy metals, there's no mercury, lead, and they need to be run in very cold environments, or the temperature needs to be maintained, is another way of saying that. A little bit about the applications. I'll talk a little bit about architectural, retail and residential. Architectural is all about the sizzle to provide effects, colour changing, facade lighting, accent area, and that's very much about the sizzle. Retail, very much about selling the product, making sure that you provide enough light to encourage the consumer to buy the product, produce, whatever it is that you are lighting. Residential, very much about the ambience and functional lighting. Display lighting, here we're getting into providing of lighting such as museums, galleries. Here it is important to maintain contrast. If you look down that hallway there, you'll see that there's areas of light and dark. That's not poor lighting, that's been put in there by design to provide some depth to the environment and to highlight the museum artifacts. To go back to that colour temperature, it's important to maintain that colour temperature you see there. We spoke about the 3000 Kelvin. 3000 Kelvin refers to the colour temperature. That is considered warm, whereas 6000 is considered cold. 6000 provides an aggressive area. You would see this colour of temperature in hospitals. It's very functional. It's not meant to make you feel comfortable. McDonald's and a lot of fast food retail outlets will use higher colour temperature lamps to encourage you to leave, whereas restaurants would use 3000 Kelvin temperature to encourage you to stay, to make you feel more comfortable. Spoke a little bit about the museums and galleries. Also another point to here is to make sure that we don't provide UV or infrared. This could damage the artifact that you're actually lighting. LEDs don't produce infrared, very little, and they don't produce any UV. It won't make your client very happy if you damage their artwork, which could cost a lot more than the quality of the lighting that you put in. Retail lighting. The essence of retail lighting is to make sure that you have plenty of impact, high levels of light, much higher than the shop next door, much higher than the ambient light, encouraging customers to come in. Colour rendering is important to reproduce the image of the product or produce so that it is desirable to sell. I'll show you a little bit an example of that in a minute. You You can see various techniques of contrast again, and lighting the perimeter to again provide a visual depth of the environment. We spoke about the colour rendering, and you can break the colour rendering into different categories, but certainly the higher the colour rendering, 90 to 100, the better that colour rendering is. The high definition lighting, to use a television term, whereas the lower colour rendering, the colours are washed out. Here's an example. Image on the left is a colour rendering of 62. The image on the right is exactly the same product but lit differently. Certainly the one on the right is more appealing, more likely for individuals to purchase. The image on the left, it's cold, it's uninviting, the colours are washed out. This is the essence of retail lighting, to increase that amount of light and increase the colour rendering to ensure that you sell more product. I spoke a little bit about each. I've just flicked through a few images. I may stop on a few of them, but certainly we're at the point now of questions. Interior lighting, where it's done well, actually adds to the visual environment. We spoke about that in the first slide. The use of colour can certainly add another dimension to lighting. Retail, here's a perfect example of some very good colour rendering. The reds of the apples and the greens of the apples are very appealing, and certainly this supermarket, since they've moved to LED, has increased their throughput of product that they sell. Another retail store, the name is up there, I won't mention it, selling bed and apparel and certain other sleeping instruments. You'll see a lot of contrast there. Dark areas and light areas on the ceiling. That isn't poor lighting, that is done by intent to provide a much more appealing atmosphere and an appealing environment, to give you some depth to that environment. Facade lighting, again, because LEDs last so long, you can tend to put them in applications where they're part of the building now. So you could bury an in-ground uplighter with a certain degree of confidence that the life of that product doesn't mean that the product has to be replaced or maintained. So you see a lot of facade lighting, and anyone that's ever been to Shanghai or Hong Kong will see facade lighting gone mad with LED. Here's a project we did in Sydney just recently, and you'll see all the aspects I mentioned earlier about contrast of lighting, good colour rendering. LED was selected in this application because they wanted to dim the lights, but they wanted to maintain the colour temperature. Most lamps outside of LEDs, as you dim them, they change their colour temperature. The client didn't want that. They wanted constant colour temperature at variable intensity or variable illumination. This application was allowed to do that through good quality LED. Iron Man. We have some more museum images here. A lot of indirect lighting used here. So you'll see the ceiling is lit very well, and then you'll see the track with LED projectors on. You can see the shadows around the frames of the paintings. That's again to provide very much directional light, as well as a lot of surround illumination. Don't always have to light the ceiling. In some cases, you'll see here a higher contrast because the ceiling is not lit. Concerts and theatres. So that's a quick roundup. I'm very much at the end. I don't know how much I've done or how much I've overrun, but we spoke about the benefits of longer life and lower use of mercuries, or no use of mercuries, UV radiation. You have a lot more flexibility in architectural design. You have a lot of advantages about efficacy and control and dimming, but the nemesis of LED is temperature. It is very important to make sure that you maintain that temperature, otherwise you will necessarily put in an expensive luminaire that won't last. So in conclusion, LED technology does provide benefits for the environment, but it's incumbent on lighting designers to make sure that lighting to the best practice to provide a comfortable and lit environment is maintained, as well as energy efficiency. Lighting development, LED technologies originally were indicators, and then they started to replace filament lamps in incandescents and halogens. Then they started to replace compact fluorescents. That will keep increasing until LEDs will provide a solution for most current light sources. A little bit more and more reading, I mentioned those earlier, so certainly I'd refer you to standards. And I'd like to thank you. Is there any questions? Can we get a copy of the presentation? Yes, absolutely. No problem, Carl. It's actually Mark Demir. I'm logged on as Demir. I'm Mark West from Sylvania Lighting. Thanks. So I suppose if I may wrap up very quickly, it's no problem, Carl. I look like a Demir. Certainly, if I can just wrap up quickly, I'll answer your question in a second, Justin. It's important to you, if you care about lighting, if your client cares about lighting, if you want to light to best practice, it's important to use a lighting designer. And whether or not you choose to use any of the brands you've seen, I would encourage you heavily to use lighting brands. Some of the principal lighting brands, they will provide you better quality assurance and give you your environment Sorry about that. Sorry, Justin is an electrician. He's having trouble selling quality fittings to the client based on pricing. The cheaper fittings offer the same benefits, long life and efficiency. Can you comment? Yes, certainly. The advent of LED has brought in many new players into the lighting area, a lot of disruption. There's very little guidance in the standards to allow you to make an informed choice. It is difficult to sell what appears to be the same product at a higher price. The only reference I would say is this is a highly sensitive technical product. If you don't use the right product, then it won't last. It's not unusual. You get what you pay for. You hear comments like that. My job here is not to cast aspersions on other suppliers or indeed suggest that Sylvania is better than anyone else, but you do get what you pay for. Downlight are penalised in how you... So Peter mentions about downlight being penalised by the building code. Certainly 50 watt downlights, the tungsten halogen downlight, that's all but dead. That lamp is being withdrawn, removed. 35 watt tungsten halogens are again less energy efficient. A good quality LED will be in the region of less than 10 watts, and you can get 1,000 lumens out of that. In a watts per meter square with a wide beam angle, you shouldn't have any problem complying with the BCA. When I mean a wide beam angle, you need a 60-degree or wider area for residential. That's not providing any contrast, that's providing general illumination. If you want to be in a display area, then I would suggest you go more with a contrast area. Any comments on drivers? Very good question, Carl. We've traditionally been in the lighting market where we have control gear that lasts forever and lamps that need to be replaced. That's where we've come from. The opposite is now true of LED. A good quality LED with thermal management will last indefinitely. The driver will not. It is very important to maintain the temperature of the driver as well as the LED. 70,000 hour drivers are few and far between, and again I would urge you to select a principal brand for that. Is there any other questions? Certainly, I'd like to hand over now to Demir, who's going to ask you to fill in a questionnaire. Please, if you could do that, it would be much appreciated. All right, thanks, guys. Here's the company contact details. We'll get the company contact details to you very soon. There you go. Here's Demir.